Hi, this is Analytic Methods for Lawyers, and this is an introductory lecture on introducing Wolfram language. I'm Seth Chandler, a professor of law at the University of Houston Law Center. This notebook, unlike many of the others in the course, is really designed to supplement some other materials. And really, you shouldn't be looking at it much until you've done some of the prerequisites. So what are we talking about? I'm talking about, for example, the hands-on start to Mathematica 12. I also want you to have taken a look at Stephen Wolfram's book, Elementary Introduction to the Wolfram Language, second edition. That's also online. And I want you to have looked at these chapters, the preface, the practicality, starting out with elementary arithmetic, introduction to functions, first look at lists, patterns, expressions and their structure, and what we haven't discussed. I also want to make sure that you've looked at the fast introduction for math students, these chapters, and you should have looked at the fast introduction for programmers, which is going to show you how to write some idiomatic Wolfram language code. Here are the chapters I want you to look at. There will be a little bit of overlap between all these materials, but I feel like it's sufficiently important and complex that a little repetition is warranted. Okay, so that's the background. What I now want to do is fill in some gaps or emphasize things, and I want to break that up into a discussion of the kernel, the front end, how to get help, common mistakes, and warnings and errors. Let's start with kernel features. And just to emphasize again, remember Wolfram language, essentially the way most people use it, it is two programs. It is a front end, which you can think of as being very much like a web browser, or if you've used, for example, the cloud version of Outlook or other software, this is what you work with. But it's not necessarily doing the computations, the hard stuff. Instead, just like a web browser basically is to package up stuff that you put in and then to format stuff that comes back from the web, there's another program called the kernel, which takes your submissions, it does all the hard mathy stuff, submits stuff back to the front end, and then renders it. That's the conventional workflow with Wolfram language. Now, as it happens, usually, although not always, the kernel is on the same machine as the front end. So it's like having a web server and a web browser on the same machine. But A, that doesn't need to be the case. And in fact, if you're using things in the cloud, it's a little more tricky in that you have a cloud-type browser which is communicating with a cloud-type kernel. But let's talk about a list of things in the kernel I want you to understand. When you have a function, the arguments are enclosed in a square bracket and separated by commas. Okay, so it's f of 3, 4. It is not f of 3 space 4. It isn't f of parentheses 3, 4. These are bad. This is the right way to do it. Okay? No semicolons. Wait, you could. It would be really weird. Don't put semicolons in the arguments. Okay? So, that's how you write a function. There is a role for parentheses, like if I want to say 3 times 4 plus 5, okay, which do I mean? Do I mean 3 times 4, 12, plus 5, 17, or do I mean 3 times 4 plus 5, which is 27. So to disambiguate that, I could put the parentheses where I thought them appropriate. Okay? But parentheses are not used in Wolfram language to designate functions. Number 2, symbol values generally apply across notebooks. Just like in a web browser, you can have multiple tabs open in every modern web browser, so too with Wolfram language. Here I'm about to go open a new notebook, and I'll bring it over here. Okay, so the question is, supposing I say x equals 5 in this notebook. Okay, now just watch this. I'm going to hit shift return, ship it off to the kernel, the kernel says, oh, 5, and it returns 5, which is now rendered in the front end. I now go to a new notebook, and the question I have is, what is X? Is X something that it's never heard of before because it's a new notebook, or is X 5? So let's execute this, and you'll see it's 5, okay? That in general, kernel definitions span notebooks. All right, let's get rid of this guy. It's also important to understand that kernel definitions do not generally span sessions with Mathematica or Wolfram language. Supposing, for example, I'm done for the day and I want to save this notebook and kind of wrap up. So I save it in the usual way, and now I'm done. I might want to work on something else. So I don't want to quit. I'd really prefer not to. So I'm going to say quit the kernel. And that means tell the kernel to shut down and forget everything. Do I really want to do it? And it's asking me for precisely the reason that I'm going to tell you, which is that I'm about to lose everything I've done. Okay, so now I've quit the kernel, and now I want to know, hey, what's X? And you'll notice, perhaps, that it's blue rather than black, kind of a navy color. That means I don't know what it is. And when I evaluate it by hitting Shift Return, it's going to tell me I don't know what it is. And when Mathematica doesn't know what something is, it just spits back what you gave it. So, kernels span notebooks but do not span sessions. So there are ways around this, but in general, once you quit, you've lost your kernel work, but not your front end. Okay. Number 3, functions. There are lots of ways to define functions. These are all what are examples of pure function objects. I haven't given any of them a name at this point. They're just something that does something. And this says, I designate it by using the head function, my usual square brackets. What am I going to call my argument or arguments? Well, here there's just one argument, and it's X. Okay? What do we do when we see something in X? We multiply it by 3. Okay? That's one way of defining the function. Another is to say, why do I really need to introduce letters here? All I'm really saying is when you see something, multiply it by 3. So you can think of this little hash sign or pound sign as something, whatever you confront. If you confront more than one thing, it's the first something. We'll talk in a different video about multivariate functions. Okay? But gosh, it's so burdensome to write out the word function. So is there a shortcut? Wolfram language has lots of shortcuts. So here's a way of writing it in shortcut. I just write what it does, 3 pound. And to tell it's a function, instead of typing all those letters, I just type an ampersand. Finally, here's yet another way. This is more of a mathematical looking way of defining a function, where you sort of say what you're going from and what you're going to. How do you make this thing? Watch. Vertical bracket, hyphen, greater than sign, space. And the front end, which is an intelligent program, magically converts it into something that's kind of nice function notation. Thing 4. If you want the exact numeric value, Wolfram language loves exact numbers. It's very proud of its exact numbers, and so you can get answers like this. And, that's lovely, but I don't know what number that is. So if you put n in front of it, it will compute the numeric value. I'm going to talk later in the course about the difference between set, for which you use an equal sign, and set delayed, for which you use a colon equal. When you see an equal, that's an immediate assignment, whereas colon equal is a delayed assignment. I think you can see this best by an example. Supposing I say y equals 8. And now I want to write a function f that says f, every time it sees a y, it defines that, notice I used an equal, to be 3y. Okay. Oh, and let's stick this into the kernel. Okay. I define this function. There we go. Okay. So, what happens if I say, what is f of 5? You might think, oh, it's going to do 3 times 5. But in fact, when it saw this y, it said, well, I know what y is. Y is 8. And so no matter what you put here, you're always going to get 24. So usually if you're doing function definition, where you've got patterns on the left-hand side, you don't want to use an equal sign. Not always, but, oh, this is number 6, isn't it? Not always, but usually. So what I probably meant was f of y colon equals 3y. And now, if I say what is f of 5, it means 15. On the other hand, if I want to set the value of something, it's not a function, it's just a value. And I want to say temperature equals 58. I don't want it to wait around. I want it to know right now, from now on, temperature is 58. So when I say, what is temperature minus 32 divided by 9 times 5, it doesn't need to ask me, hey, what's temperature? It knows what temperature is. So here I'm using an equal sign. All right, and that was basically item 6. So the rule of thumb is for functions, use colon equal. If you're assigning a value to a variable, generally you want to use just regular equal. There's an analogy we'll talk about later with rules. Okay, so I'm going to delete this output. Naming conventions. All Wolfram language built-in functions start with a capital letter. Okay? That means that it's often a good idea for your own functions to start with a lowercase letter. That way you'll know this is something I wrote or this is something Mr. Wolfram wrote. Now, you can violate that. You're free to do so. It's a suggestion. The other thing, what's camel case? So camel case is something like this. User-defined variable. Okay? So every time you encounter a new word, you capitalize it. And so visually, this is, people can read this, whereas I think people have a harder time reading this. Other languages use underscores for the same purpose. User-defined variable. Wolfram language doesn't like underscores in variables. It reserves the underscore for a different purpose. If you really need it, I'm going to tell you a secret trick. User escape ls escape defined escape ls escape variable equals 4. That's okay. And so if you really are coming from some background and you really like underscores in your variable names, use escape ls escape. Okay. So for example, this function, if I write, here's a function I'm going to write h of x is equal to 3x, and I'm going to write h, capital H, of x is equal to 5x, and I now say, what is h of 4? It knows, oh, you mean this h, lowercase h, and so it's going to give me 12. Okay. Why did that fail? That's instructive. It spat back at me. The reason it spat back was, see how there's no little in there? That's a clue. And you see how this is blue? That's a clue that I have forgotten to tell the kernel, hey, you need to know this. Okay? I can write things and never tell the kernel about them, and so the kernel will never know. Usually you want the kernel to know something, and so what I forgot to do here was hit Shift Evaluate. Now we have an input number, and now when I type h of 4, I'm going to get 12. I'm not going to get 20. If I wanted 20, I could do capital H of 4. Okay? By the way, these input and output numbers are just sort of a sequence. It's like your history of using the language, or in a session. when you start a new session, you will get new sequence numbers. Is that true? That is true. Number 2. I did number 2. Number 3. Functions that end with a capital Q almost always return Boolean values. And by Boolean, we mean true or false. And in Wolfram language, every language has a convention on how you represent truth and falsity. In Wolfram language, it's capital T, true, and capital F, false. Okay? Not these other ways, not ones and zeros. And so functions like member Q, numeric Q, association Q, there are a lot of Q functions. They all, in fact, here's one way of maybe seeing a bunch of them. Lot of Q functions. Because it's very often important to know, hey, is something true or not true? They return a Boolean value. There are, however, you should know, Wolfram language functions that return a Boolean value that don't end with Q. So greater, for example, if I say 3 greater than 5, it's going to return false. Okay? And actually, that's very confusing to you. Let me do it this way. If I say greater 3, 5, that's going to return false. I don't write it as greater Q because the function name is greater. And I guess this is just, it's like languages where there are sort of irregular verbs. These are the irregular verbs. Number 4, functions that look like another function but have an n in front of them generally return numeric values rather than symbolic ones. So if I say maximize 3x squared minus, actually that's going to blow up, minus 3x squared minus 6, maximize that for x, it's going to say, oh, that's maximized exactly at 0 with a value of negative 6. On the other hand, if I say n maximize that, not only is it going to return a subtly different value, see the decimal point here? That means it's approximately 0. Now, as it turns out, the correct answer is 0, but it's saying it's approximately 0. And it's also going to use a different type of internal method to figure out where this function is maximized. So in general, if you see a function and then the next word, you see an n at the beginning, and then you see a phrase that looks like another function, that means it's using a numeric method. There's another naming convention. Functions that start with find, like find minimum, find formula, find fit, find cookies, are generally doing approximations. So here's one, find formula. It's looking at this set of numbers and saying, I wonder if I could find a formula that fit this pretty well. So it's thinking, and this is telling it, by the way, to express that formula in terms of x. And it's actually, today it's decided, you know what, x squared fits that really well, which is true. Good job, Wolfram. Number 6, functions that have the word plot in them tend to make pictures that you can decorate. Functions that have the word chart in them tend to make more elaborate pictures. Okay, so I could say list plot point 3D. See the plot word there? And this is just going to make a list of random points in 3-dimensional space. On the other hand, let's look at this. Here I've got some data, and this is how many people are in each of these Latin American countries. I'll evaluate that. And the reason this is taking a moment is it's actually going out to the web right now and figuring out, hey, what do I know about Bolivia? And now I could make a geo-bubble chart of my data, and I only want to look at South America, and it's going to make this a fancier chart than something like this. We've got all sorts of, there's the Amazon and country borders. So chart makes sort of pre-built fancy things. Plot is a little more basic. Number 7, Wolfram language does have constructs. If you're coming from other languages, loop-oriented languages that love do and while and for, They do exist in Wolfram language, but if you use them, you're going to be scorned. There are usually better ways of doing it. And to see better ways, look at my code, look at Stephen Wolfram's code in the documentation. The only person I ever saw use do and while was the Nobel Prize winning economist John Nash, who after emerging from basically, I mean, this is a very sad story, schizophrenia in which he was basically unable to function for 30 years. He had memorized programming constructs that were popular back then, and so he liked Wolfram language, but he used it in this disfavored manner. Number 8, if you want to know how to write idiomatic Wolfram language code, there's this website here, and you can find a lot of examples. In fact, I think what this website is, as I recall, is it's a list of other places where you can find good examples. Let's close that up, and let's talk about front-end features that I want to emphasize. Okay, here's the thing everyone gets wrong the first time they use it. They're all ready, they've got their formula, and they're going to write 4x. They remember putting a space, and then they hit return, and it just goes down. What you're forgetting to do is it's not return, it's shift return. It's a chord, two key chord, and so you press them at the same time, and that's how you get things to execute. Supposing you mess up, you put 5x equals 8, and I execute that. Actually, let's try something a little better. Let's do, first of all, let's just cut that. Notice these are the cell brackets here. I've put my cursor over them, and now I'm going to hit Control X or Apple X, and it's gone. Let's suppose I say x equals 93, and I run that. And you know what? I realize I didn't really mean that. I could try to hit Apple Z, and that will get rid of the last line of output. So that's sometimes useful, but is that just telling the front end to get rid of the last line of output, or is it telling the kernel, hey, forget what you ever learned about x? Let's see, if I say what's x right now, it's a bad sign that it's black. That means it's probably defined, and it still thinks it's 93. So, by the way, what do you do if you want to get rid of the meaning of something? Clear is your friend. Clear will get rid of the definitions associated with the symbol x. You'll notice it's turned nice and cheerful blue, and so if I now say what is x, it says, I don't know what x is, you tell me. So, that's about Command Z. There is an exception to the rule about Shift Enter, and that's for Wolfram Alpha style input. So, supposing I'm not good at Wolfram language yet, you can basically try to write your code in more common language. Sometimes this works, sometimes it doesn't. One of the good things about learning a language precisely is that you're not subject to these translation issues. But let's try something. Supposing I want to say, what's the population of South Dakota? So at the beginning of my input cell, I hit equal. See how I get a nice orangey Wolfram Alpha equal? And now I say population of South Dakota, if I can spell it. Okay. Because this is a Wolfram Alpha line of input, I hit return, not shift return. And it's thinking, and it tells me that's how many people are there. By the way, the other thing that it's done for you is it's told you, hey, if you want to do this in the future yourself, this is basically the code that you need. Now, there's a little other issue here about how do you make South Dakota. Maybe I'll show you that right now. So I'm going to say equal South Dakota. Okay, now I've just got the entity here. And supposing I want to know the population, what I'm going to do is I'm just going to get in here subtly and cut and paste in the usual way. Did I actually do that? I don't know. There we go. Cut and paste. And I lost my brackets. I guess I didn't copy those. So there you go. Now it executes this. There's some more to it, a lot more to it. But what I wanted to point out here is sometimes people get messed up in this. If you're using Wolfram Alpha input style, you want to use return rather than shift return. Number 4 I basically just covered, which is sometimes Wolfram Alpha input can help you learn how to program. I think, honestly, I prefer just learning it the right way in some sense, the formal way, but people have different learning styles, and so you can try Wolfram Alpha input, like I could say plot, gotta spell things, sine of 3x, and let's see if it knows what to do with that. Right, so that's, okay, that's actually correct. I know it looks, oh, that's interesting. It has misinterpreted what I meant. I didn't mean plot the sine of 3 times x. I meant this. Let's see. There we go. That's better. So this is how you actually write it the nice way. But if you're at a loss, sometimes just writing it in plain English with an equal sign can help you. Okay, number 5. Sometimes when you open a notebook, you might see a blue box at the top right that says Enable Dynamic. That's sort of asking a question. And it has this scary thing, this file contains potentially unsafe dynamic content. That's, I mean, in some sense they're right, because I could put all sorts of weird stuff in my notebook that said reformat your hard drive. So if you trust the user, and you can trust me, you should press that button, Enable Dynamic. If you don't know who this is coming from, this notebook's coming from somebody you just met on the web, you might want to be very cautious before you press Enable Dynamic. You might want to take a look at the code and see if there's anything, you know, that says erase all files that have a creation date later than last year, something like that. Okay, so that's the Enable Dynamic thing. If you see it in one of my notebooks, you're just going to have to trust me that I wouldn't erase your hard drive. Number 6, all these functions. Who the heck knows what they mean? So one quick way to find out what they mean is, here's a function fold. I hit Shift Apple or Shift Command F, and now up pops up a big set of documentation. Let me just get this into my video window here. Okay, a big set of documentation that's going to tell me everything I ever wanted to know about fold. How to use throw with fold, basic examples, 9 different applications of fold, all sorts of great stuff. But my point is, Wolfram, one of the great things about Wolfram language is its incredibly large and organized documentation system. And one quick way to get access to it is to just mouse over the function and hit Control-Shift-F. If you want to go directly to the documentation, there's a menu up at the top that basically has the help, and it's going to say Wolfram documentation, and it's going to bring up something that looks exactly like this. And then you're going to say, oh, I don't know what this is. So maybe you think it's core language, and you think it's functional programming, and now we get a list of all the functional programming constructs, and there's fold right there. So there are other ways of using the help function. It's extremely extensive. I don't know, let's suppose I want to know about trigonometry, something that we're not going to cover in this course. It's just, so here we go. It's going to give me, here are a list of trigonometric functions. Here are tutorials on trigonometric functions. Everything one would ever want to know about trigonometric, goodness gracious, functions. Okay. Number 7, every programming language I know has an ability to say, I don't mean this as code. Now, it's a little old school because the right way to do this now is to just have a text cell that just says, the following adds two numbers together, and I change that to text. So I don't need to comment the code, but sometimes it's still useful, and you'll see it. How do you tell the computer, hey, I don't mean this as multiplication or something. This is not we times should times get times 8. Just enclose it in parentheses star to begin with and star parentheses to end it. So that's the commenting system. Iconization, number 8. This is a great feature of Wolfram language. Okay. Oftentimes you want to draw someone's attention to the important stuff in code. And yes, there's a lot of other stuff going on, but there's no real need for them to see it. If they want to see it, they can. But generally, supposing I want to explain to you how the plot function works. The plot function has a million options that are actually sort of buried underneath this thing here. But what I really want you to see is the basic syntax of it. So what I've done is to iconize, to turn into an icon, all that extra code. If you want to see it, click on the little plus sign. It's going to tell me that there are 39,000 bytes of stuff in that icon, that it has a head of sequence, and I can say, you know, I really want to see it. I want to know what you did. Uniconize. And there it is. There's all the stuff there. And I say, huh, that wasn't very interesting. Supposing I want to re-iconize it. I'm just going to run my mouse over it. Run my mouse. There we go. I'm going to right-click on my mouse, and there's the little iconize. See how much prettier? So this is a form of code hiding that lets you hide in code that's of secondary importance for your purposes, but does let the user see it if they want to. I will make some significant use of iconization. Closing and reverse closing cells, number 9. Okay, supposing, here's some code I've written, 3 plus 2 and it outputs 5. Supposing I just want the user to see the input, I don't need to see the output. If I double click on this bracket here, not these two brackets, but not these two brackets, gosh darn it, it's grabbing, not this bracket and this bracket, but this bracket, if I double click on it, click, click, it suppresses the output. It's still there if I want it. If I double click again, back it comes, but it's sort of like I've just hidden it away. Sometimes I don't want to see the user to see the input at all. This is sort of extreme iconization. In that case, I'm going to go to the output, click it, and double click it. Double click. And now you just see the output. You don't need to know how I got to this thing. The important thing is the result. Okay? So it depends on what your intent is. Number 10, to suppress output from code, end it with a semicolon. Okay? So supposing I don't need for the user to see it, or I don't need to see it. Supposing I've got some big long piece of code, it is going to produce some output, but what's really important is just to see what the program was. End your code with a semicolon. And you will notice I end my code with a semicolon a lot, as do lots of other programmers. One other advantage of entering it with a semicolon is sometimes presenting the output in an aesthetically pleasing fashion takes a lot of thought on the part of the front end. Save yourself the trouble. Tell the front end, take the day off and use a semicolon. Number 11, another use of semicolons. You can have basically a compound expression, and here's a compound expression. The first thing to do is to say a equals 3 plus 4, and now in fact I want, let's do 3a, okay? So now it's output 21. That is the single output from this compound expression. And I've just told it, hey, these are two separate programs, as it were, and I've separated it with a semicolon. Number 12, Control L is your friend. Supposing I want to grab, I could, of course, copy this and paste it, but oh, how burdensome that is. So, supposing that's what I want to do, I just want to get the last thing I typed above it and bring it down. Control L. Okay? Number 13. If you're using the default style sheet, there are a number of style sheets that are available, or the computational essay style sheet that I'm going to be using a lot in this course, the front end provides a lot of helpful information by color coding things. So symbols that have been evaluated, that is not correct, unevaluated symbols are in blue, defined symbols are in black, there are other codes of interest. So you see here, and let me in fact magnify this. I'm going to magnify it up to 300% by going to the window magnification 300% option. And you can now see how it's sort of a, I don't know what you call that, Dodger blue. So now when I evaluate it, see right now the front end's sort of asking the kernel, hey kernel, you know anything about C? And kernel's saying, no, I don't know anything about C. So the front end's saying, well, in that case, I'll make it Dodger blue. I evaluate it, and now the kernel says, now do you know something about C? And the kernel says, you bet I do. I know it's defined as 7. So now C has turned to black. Okay? It may seem simple, but it's a very useful part of the development environment for writing Wolfram language code. Okay. Other colors. Let's go back to regular levels of magnification. Again, I'm going to go to the window menu, magnification 100%, which is what I use in this course. And so sometimes you'll see things in teal. A symbol in teal means it's defined within the scope of this expression. So here I'm saying, let x be 5 and add 5 plus 2. Okay, I do that. And now I say, what's x? And you'll notice how it's blue. Remember what blue means? Dodger blue? Dodger blue means I know nothing. And that's because this definition here is local. It's only operating within the scope of the with statement. And the color coding helps with that. Number 15, if you use funky style sheets, color coding of syntax doesn't work as well, which in my view is a real deterrent to use of funky style sheets. Item 16. Wolfram language has a lot of shortcuts that improve the appearance of code. Sometimes, however, you want to see under the hood and you really don't want the shortcuts. So input form, for example, here's some input, and it's very two-dimensional. You've got a fraction bar and then a radical sign and then a little tiny square thing there. Here you don't, I'm not making use of the fraction bar, I'm just doing division sort of the old-fashioned way. What if I want to see this in a simpler one-dimensional fashion? Input form does that, and that's because y is now defined. Okay, that's why I changed, so let's clear y, and go back, and reevaluate, and now it looks like it did before. Full form lets you see how the kernel thinks about the expression. This is often very useful in sort of trying to get to the bottom of what's going on. So we'll execute this, and we're going to see how does the kernel think about this expression. It thinks this is plussing. What am I plussing? This is one thing I'm plussing. This is another thing I'm plussing. This is another thing I'm plussing. What's this first thing? This first thing I'm multiplying. What am I multiplying? Well, I'm multiplying something that starts with a power. And the first part of the power is 5. And what am I taking that to? I'm taking it to the negative 1/2 power, which is sort of 1 over the square root. And so this is a much more formal way of thinking about math. You can see why this would be very inconvenient if you had to write it out this way. It's very hard to communicate because this is not how humans really think. But if you want to see how the computer thinks, how the Wolfram kernel thinks, use this. Full form's also useful if you don't know what an operator means. Like supposing you see something like this, just wrap it up in quotes and say full form, and it's going to tell you, oh, this means function. Tree form. Tree form is a little bit like full form, and it lets you see various levels of the expression. Like at the top level, this is some kind of sum. The terms are a multiplication, a power, and a power. And what's the first part of the times? At the next level, well, that's a power too. And so sometimes tree form is useful, particularly if you find yourself needing to use levels. And I haven't covered what those are, so that comment's completely mysterious. But trust me, when you got levels, you might want to use tree form. Subscripted variables. It would be kind of nice if it were easy to say x sub 3 and x sub 5. That is not so easy in Wolfram language. I would urge you to avoid it. Number 18. See how I write x with a nice little 3 up there to mean x cubed? I could write it this way. X caret 3. Wolfram uses caret to mean power. You can use either, but if I want to make the nice pretty 3 up there, I'm going to, instead of using caret, I'm going to use command caret, that chord. Okay? Also, if you're using Wolfram language in the cloud, that does not allow you to use superscript. So you will not be able to do this right now. You'll have to use this older method. Supposing I want to divide a cell in 2. I just put your cursor where you want the break to be and hit Shift plus Command plus D. So I'm about to do that. Shift Command D. And now I want to put them back together again. I select both the cells and I hit Shift Command M. And they're back together again, although it looks like it kept that space. So there we go. That's some front-end things that I notice are hard for beginners. Let's close up those front-end features. Okay, for this part of the recording, you're probably going to benefit from seeing, I hope you can see my whole desktop here. So how do we get help? One way is I go to help, I go to help, and I click on Wolfram documentation, and this lovely documentation system thing comes up, and I can now navigate it. And maybe I have a question about how to use, I don't know, financial data, and I want to know how to do a blockchain. And so now it's going to tell me some information about how to get information on blockchain data. So Wolfram has an enormous help system. Every function has a reference page. This is a reference page. It's got all this stuff on details about how you might use the function, examples. It's got notes on what you can use it for, options to the function, what those options do. We've got related functions. We have guides. That is, these are areas of functionality that might list blockchain data. So here's a guide page. That, again, it's another way of getting at related functionality. And you should know that there are, when you install Wolfram language on your desktop, you get the whole help system, but there are also versions available online if you would prefer that. Okay, so this is simply a picture here, actually, of the map function. So I guess what I did is I built a little picture of what you would get if you typed in map into the help system. And it has its own little home page. It's almost like a mini web browser. Okay. Here's what a guide page looks like. There are tutorials. So sometimes the tutorials are really helpful. So let's type in pure functions, and it's gonna find me 6,714 entries. Well, that wasn't very helpful, was it? All right, well, that didn't work so well. But also there's the book. There's the Elementary Introduction to the Wolfram Language book. Let's bring that in. I guess you don't really need to see my email, do you? So we'll just get rid of that. And here is the, no, this is not the elementary introduction, is it? Let's go to the Elementary Introduction to the Wolfram Language, 2nd edition. And it's got the whole book. You can buy it if you want, but here, supposing I want to learn about basic graphics objects. So here's how you make a circle and a disk and three-dimensional, and it has exercises. So you might think about doing some of these exercises, and in fact, it says you can check your answers in the Wolfram Cloud. Let's see if that's true. Use regular polygon to draw a triangle. Okay, well, I think I actually know how to do that. So answer and check your solution. Okay, let's do it. Let's see if Professor Chandler can do an elementary exercise. All right, it's filling this up. Click to enter code. All right, and I'm going to say regular polygon. See how it's helpfully filling it in. And when I went to school, triangle. All right, let's see if that's true. I go here. I'm going to take this. I'm going to type in some output. I'm working in the cloud now. And I'm going to wrap graphics around regular polygon of 3. And I'm going to say check my solution. And yay, I got it right. Okay. So this is a good way to learn Wolfram language, is to just work through the exercises. Let's close that down. Let's close that down. Let's move my web browser out of the way. Let's get that. All right, so that's one source of help. Google and YouTube are really useful. So just use those in the way you use them all the time. If you get stuck with something sophisticated, there are 2 help communities. One is Stack Exchange has a help community. Let's see if I can show you that. Let's do mathematica.stackexchange. And so here's questions. Usually these are fairly advanced questions, but they have a search facility. So I don't know, supposing I want to know how to make a bar chart. All right, and so all sorts of stuff on bar charts. So that's one thing we could do. Also, there's community, community.wolfram.com. This is an in-house help forum where people submit questions and people submit answers. So all sorts of really elaborate stuff here. I sometimes answer questions here. I sometimes submit questions here. And so again, it does have some search capabilities as well. Either one should probably work for the kind of questions that you have. Goodness, we don't need that. We don't need the Constitution. In fact, we really don't need my web browser open. Okay. Common mistakes. So those are how to get help. Let's turn now to common mistakes. And to do that, I'm going to go back to my usual way of presenting stuff, where you don't see my whole desktop, you just see the notebook that I'm working on. Common mistakes. Okay, this is a classic. Let's suppose I say I want b to be 6. Fine. Now, you know what? I've changed my mind. I want to use the symbol b, but let it be a function. I want to say, if you see b of x, let that be equal to x plus 5. I evaluate that, and it fails, and I get a mysterious message, tag integer 6, what's going on? So what's going on is, when I wrote b, it said, oh, I know what b is. That's 6. So I'll think of this as 6 of x, but that doesn't make any sense. 6 isn't a function. So what we need to do here is to clear b. Clear, if this message, the response is just clear it. And now, doesn't know what b is is just a symbol, so this is going to work splendidly. Second big mistake, using equal when you mean equal equal. Equal is for assignment in Wolfram language. In R, they use, this is what the assignment is. It's a backwards arrow. Some languages say let. Most languages use equal, and Wolfram uses equal. But when you want to test for equality, when I want to say solve for the conditions under which it is true that z equals y plus 50, I need to use those 2 equal signs in a row. Also, you'll notice when I do this, my equal is red. Red is almost always bad. If you're seeing red in your input, the odds are very strong that you have made a blunder. And by the way, if I persist in this, it's going to cause all sorts of problems. Let me just show you what happens. I do this, it's very confused, but now Z is defined. And so now when I say, oh gosh, I remember. I should use equal, not equal. So I do this. And now it's not going to work. Why? Because Z is y plus 50. So it's telling me, tell me the values of y under which it's true that y plus 50 equals y plus 50. And that could be anything. So it's not really able to do conventional algebra on this. Okay? So what's the solution? The solution is to clear Z. And now we're back in business. And now it knows how to do the problem. Let's restore this back to its earlier bad state. Finally, warnings and errors. Okay. If you see red, bad sign. Okay, this means in 12.2, this drawing can be much more helpful. It's going to tell me, look, y-axis is not an option. Magenta. It uses magenta to match brackets as you're typing along. And so when things are left magenta, when you're done, that means your brackets aren't symmetric. Like here, what's my problem here? The problem here, for example, is I need a second brace right there. That got rid of that magenta-ness. And once I got rid of that, then it's all fine, actually. Then all the braces match up. Okay? So when you see magenta symbols, particularly like these brackets or braces, that's a problem. Division by zero. No computer system likes division by zero. And so if you get infinite expression 1 over 0 encountered, that means one way or another you're trying to divide by 0, which we don't do. Okay. Now, pink. Doesn't like pink either. Pink is a sign that you've made a mistake. In the output is a sign that you've made a mistake. So what's going on here? I have a perfectly fine graphic. And here, see that little red caret? That means too few arguments are given for square. Square needs to know there are no sort of abstract squares. You have to tell it something about the square. If I put square of 4, then, now what's wrong with it? It's still pink. Square is, right, of course. So square isn't a graphics primitive at all. So putting a 4 doesn't cure anything. And so this is actually a fairly helpful error message. Square is not a graphics primitive or directive. If I'd read that in the first place, I wouldn't have messed up. You'll also notice this here, this red bracket, cell bracket, that's telling you it's got a problem. If I click on plus, over in the corner here, I'll bring it into this window, it's going to give me the content of the message, which is really the same thing we've seen before. So pink is bad, magenta is bad, and red is bad. And you'll notice when I type stuff, I generally try to avoid those colors. Particularly in graphics, I try to avoid pink because it's confusing as to whether I've made a mistake or not. So this brings to a conclusion a little discussion or a long discussion of an introduction to the Wolfram language. We're going to be using it throughout this course. I've got one more major notebook on it, which is going to give you 100 vocabulary words for Wolfram language, and one short video on how to use Wolfram language in the cloud. Thanks.